Hello guys, in previous video we set up the PID compact, and in this video we will configure and commission this PID block. First we will configure it. For configuration we have to press this icon, open configuration window. It will open this page, and in this there are some settings to change. We'll check one by one. First one is controller type. I have put this in the volume. Actually in beginning it will be in general category, doesn't matter in which one that is, but since we are in a level control system I will put this in volume, and the unit will be in liters. Then the invert control logic I will not tick that. Then comes the activate mode after CPU restart. That means if we restart the CPU, the default mode will be manual mode. We can change it if we want. There is automatic and manual mode, and fine tuning, pre-tuning, inactive modes also. I will put this in manual mode. Then we will move to the next setting, that is input output parameters. In this there is two options, input and input PR analog. If the process value is analog value, then we should go for input PR analog, and if the input value is a real value or a tag, then we should go with the input. In previous video I told you that I am mimicking a sensor from this cyclic interrupt block, so I will go with the input here. In the output there is three options. One is output PER and output PWM. I will go with the output. You can read about the others here. Then we will move to next parameter, process value limits. As of now I will put it as 0 in low limit and 1000 in higher limit, because our tank has maximum capacity of 1000 liters. I will change it later so that we can see how the warning system is working. Next is process value scaling, but it will be disabled since we are not using the input PR. Then comes the advanced settings, process value monitoring. This will be also used for the warning system, but for now I will put it 0 and 1000. Next is PWM limits. You don't have to do anything with that. Then output value we will keep it as it is now. It means if there is no output, the output will be kept at 0, and the maximum output, the output value will be at 100%. Suppose we are making output high limit to 60 and output low to 30. In that case, when PID output is 0, actual output value will be kept at 30%, or we can see that pump will be running at 30% of its capacity, and for 100% capacity of PID, the pump will be running at 60% only. We don't need this feature in this project, so I am keeping it as it is now. Next is reaction to error. Normally if there is any error, the output of the PID will be 0, but we can change it by substituting the value here. If it is kept at 20, then the output will be 20 if there is any error, but here I am keeping it to 0. Then the next setting, the PID parameters. Initially all of these columns are 0, but I already commissioned this PID block, that's why there are values in this columns. I will make it all to 0, then we will commission it again. Then there is an option for PI and PID controller. In PI there are only PI proportional and integral controller, but in PID proportional, integral and derivative controller, 3 of them are present. Now I am going to make it all 0, then we will go to the commissioning. For now I will put the controller structure to PI. We will check both PI and PID later. Now we will go to the commissioning window. Now we are going to commission this PID block. For that, first I have to upload my program to my virtual PLC. So I am starting my PLC sim now. It will take some time. Now my PLC sim is up and running. Now I will upload the program. Okay, now the program is in the PLC. For getting a better idea about the system, I will start the screen also, that is SCADA. Okay, now SCADA is working. Now I will start the commissioning. For that I will click this icon. I am not changing the sampling time. I will keep it as it is now. There's one more thing, that in my cyclic interrupt, my PID block is connected to my inflow pump switch, that is this switch, because I want my PID block to running only when the pump is active, and when the pump is off I want this PID block to off. So before starting the commissioning process I have to turn on the inflow pump. Now my PID block is active. Now we'll start this process. Now the status is showing system tuned. That's because I already tuned the system before, but in the last video I already deleted the current parameters. Now it's all 0. Now we will tune it again. First is pre-tuning. Now we'll enter some value. Now the message is showing the pre-tuning is in progress. It will take some time. If there is any error it will be shown here, but as of now there is no error. Even if there is any error we can acknowledge it, then the process can be restarted. Now the pre-tuning is finished and the message is showing system tuned. Now we'll check the parameters. Now the system gives the value, that's gain equal to 5.99 and TI equal to 3.99. But now we will fine tune the system. For that we will introduce some disturbance also. That is, I will change the set point or start the outflow form. Now the message is fine tuning is in progress. It is also a slow process. Now it's finished. Now the status is system tuned. Now we'll check the parameters. Now the proportional gain has changed to 1.39 and the integral action time is changed to 12.45 seconds. Now we can play with the system. We can change whatever level we want. It will keep the level same. We can see here that inflow is increasing now. And the system is trying to retain its balance. It takes some time to reach the set point. As we can see, the set point is 900 and it is coming to that level. Now the flow rate comes to 0. If it is reaching to the 800, the flow rate starts increasing slightly. And as you can see, the system is maintaining its balance slowly, but it's maintaining. Now I will explain the other columns. The disturbance column I am not changing because I cannot observe any changes by changing that column. This is manual value. I can put any manual value to the inflow pump through this column. Then the scale input, it's almost the same as the input level. This is the output level percentage, to what percentage the pump is running now. It is 39% on its current level, and this is more. If you want to change it to automatic and manual, or pre-tuning or fine-tuning, we can do it from here also. We don't have to go to TIA portal every time. We will change it to manual later. In this column we can see the gain, TI and TD. TD is 0 because I am not using the derivative component now. We'll do it after some time. Now we will check the manual board. For that, first I will insert some manual value. I have to insert the percentage value, so I am inserting 60%. That is 6. That is, it will be 6 here. Now I will activate the manual mode. Then I will activate the mode active button. See, the state has been changed to 4. It is now 6. The level starts to increasing because it's manual. Now we'll take it back to automatic. It's coming back to automatic, so the flow rate is coming down to maintain the value. The output flow is same as 4 now. Now we will check the PID controller. Guys, this video is getting too long, so I am going to wind it up now. I will do PID controller in the next video. Thank you.